All right, so what are we?
This guy's name is Brian,
I'm Brian.
and I'm Juan, and we're the two seniors from AP Calc AB,
Period 13.
period 6.
Period 6.
And pay attention, we're going to educate you today.
We're going to show you about the Fibonacci sequence and
The golden ratio.
exactly. And so now we want you guys to get yourselves comfortable, sit back, relax, enjoy the show, get out a bag of popcorn.
There you go. And fountain.
So now we're going to count down the Fibonacci sequence until the video starts.
55,
34,
21,
13,
8,
5,
3,
2,
1,
1,
0.
Fibonacci was born Leonardo Pisano Bigolo, and he was an Italian mathematician. He wrote the book The Liber Abaci, in which he explained that math should be done with the Hindu-Arabic numeral system. He preferred this numeral system in comparison to the Roman numeral system that was present in Italy at the time. Fibonacci became famous for his mathematical problem that dealt with the reproduction of rabbits. His answer to his problem ended up being a sequence that was the solution to that problem. That sequence became known as the Fibonacci sequence. Each term of the Fibonacci sequence is the sum of the two preceding terms and is represented by the formula. The precise cause of Fibonacci's death is actually unknown. We're going to prove that f of n plus 1 over f of n as n approaches infinity is equal to 1 plus the square root of 5 over 2, which is 5. Now, we start with the equation f of n plus 1 is equal to f of n plus f of n minus 1, and then you divide each term by f of n. So you get f of n plus 1 divided by f of n, which is equal to 1, plus f of n minus 1 over f of n. After each term is divided by f of n, you let the limit as n approaches infinity of f of n plus 1 divided by f of n equal x. Also, you let the limit as n approaches infinity of f of n minus 1 over f of n equal to 1 over x, which is the inverse. After you do that, you have the equation rewritten as the limit as n approaches infinity of f of n plus 1 over f of n is equal to 1 plus the limit as n approaches infinity of f of n minus 1 over f of n. Now with this new equation, this all becomes x is equal to 1 plus 1 over x. We're going to rewrite this equation on the next step right here. We're going to move the 1 up to the left side and multiply each by x so that you can get x squared minus x equals 1. Move the 1 to the left side, and at this point we are going to use the quadratic formula. And of course the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac over 2a. We plug each term in for each variable, and we have 1 plus or minus the square root of the quantity negative 1 squared minus 4 times 1 times negative 1 over 2 times that 1, which ultimately becomes 1 plus or minus the square root of 5 over 2. Now this is just the same thing as phi. The Fibonacci sequence can be seen in many natural objects. Inside this banana, you can see that there are 3 stems, and that is a naturally growing part of the banana. In this video, we see Stephanie drawing a Fibonacci spiral. Each square has a side length representing that of the Fibonacci sequence. So the first square has side length 1, the second one has side length 1, the and followed by 2, 3, 5, 8, and 13, 21, and 34.
Oh, pomegranate tree. Let's see if it has my sequence. According to my calculations, I should count the number of leaves and then spirals. And the number of spirals should be a number preceding the number of leaves in the Fibonacci sequence. Let's try it out. 0, 1, 2, 3, 4, 5. And spirals are 1, 2, 3. So we have the number 5 for the leaves and the number preceding 5, which is 3, for the spirals. Now we'll do 3 for those people who don't believe me and think I'm a lunatic. 0, 1, 2, 3. And then 2 spirals, because we have opposite leaves, 1, 2. So we have the number 3 and the number preceding it, which is 2. And for those who hate me, to prove them wrong, 0, 1, 2, and then 1 spiral. So we have the number 2 and then 1 spiral. Fibonacci sequence. 3 times proven. Check.
You start.
Okay, so to summarize, we gave you a little history about Fibonacci and also
We proved the golden ratio and
We
gave
sh-
some real world examples.
Yeah.
And a real world example of that is
the Parthenon is alleged to have dimensions similar to that of the golden rectangle and phi.
yep.
So, other than that, I guess, thanks for watching.
And I hope you got educated.
Come on, let's go. Yeah! Let's go! Alright, okay. Alright, okay. Return to the Mac. Get up what it is, what it does, what it is, what it isn't. Looking for a better way to get up out of bed instead of getting on the internet and checking a new hit. Get up.
Pizza? Pizza? Pizza!
I'm Leonardo de Pisa. You want a piece of me?